Okay. So now I will introduce our speakers and then we can slowly start. First on the stage will be Ante Gulin. He will speak about RPC framework from Google and how he uses it on the front end. And after him we have Janez Čadež from Slovenia. He will talk about Firebase. He and his team use Firebase in their production project, and he wants to tell us about good and bad sides about Firebase. So big applause for our speakers, and we can slowly start.
Test. Okay. Just a moment. Okay. I think we can start now. So thank you everyone for coming. My name is Ante, and today I'm going to talk about gRPC and gRPC-Web more specifically. So gRPC has been around for quite a few years now, but gRPC-Web is a new thing, relatively new, and I'd like to share my experience with it with you, and maybe inspire you to use it on your next project, or just so that you know what's happening on the web right now. So before we dive into the gRPC stuff, let me first introduce myself. So I'm working for agency 04 in research and development team. And there's nothing really too much to say about myself except that I like to make things work and I love software. So let's start. gRPC is a universal and high-performance framework, RPC framework, developed by Google. It was open sourced in 2015, and it's a successor of an internal library, which was also developed by Google and used by Google for 15 or more years now. And it was really the backbone of the Google's inter-service communication. So there was a lot of effort into making this version of RPC, and we will see more about it now. So the main usage scenarios of gRPC are it efficiently connects the polyglot services. So that means that you can have multiple services in different languages that talk to each other without any implementation problems. So it's an universal way for services to talk. It's also connecting mobile devices and browser clients with the backend services. So it's not only used for the backend APIs, but also for the user-facing APIs. Also, it generates efficient client libraries, which we will see in a moment what that's about. And some of the main core features are it supports officially 10 languages as of this moment. It's highly efficient and saves all the bytes that can be saved. It supports bi-directional streaming, because it uses HTTP2 as a transport. It also supports easily extension. It supports extensions such as load balancing and tracing and similar features. So what does gRPC stand for? It's apparently not Google's remote procedure calls, but apparently they thought it would be funny to call it gRPC. gRPC, remote procedure calls. So anyways, so this is basically the idea of gRPC. So we have a gRPC server, which is some kind of service that we want to talk to. And we can have multiple clients that are written in different languages, such as Ruby or Android Java client, that are talking to the same service via gRPC. So these are currently the 10 official languages that are supported by gRPC. That means that Google is working on supporting them and that it's official. So we have Node, Java, Go, Python, Ruby, C, C++, C#, and PHP and Dart are currently in beta. Also, some of the big players are using gRPC as their communication framework. For example, Docker, you might not know, but Docker is using gRPC for communication between Docker client and Docker daemon. So that's an interesting use case there. But it's also used by Netflix, for example, which is known for having many microservices. And they had great success with using gRPC because it allows them to have backwards compatibility with message versioning. But we will get to that in a moment. So what is an RPC? In case you're not familiar with RPCs, RPC is a way of, it's basically a way of having a function that appears to be local in your application, but it's actually on the remote service. So you call a function that is local in your application, but it's being executed on a remote server. So, for example, we have a function called divide here. We're calling that function on the client, which is on a host A, and the actual execution is happening on a service that is on host B. So let's take a look at the Rpc Life Cycle. So first thing that happens is us developers invoke a function in our code base. So once the RPC function is invoked, firstly the RPC framework will take the parameters of the function, and it will serialize it in a wire format that can be sent so that it can be sent over the wire to the remote service. So once it's marshaled, it can be sent over the network, and then when the server receives the message, it is deserialized, and the function is being executed on the service. And once the execution completes, the process goes backwards in all the steps like we just described. So that's a basic RPC lifecycle. So in order for a RPC to work, there must be a way of describing a service interface. So we must be able to define how does our services look and what are the messages that we pass between those services. So by default, gRPC uses protocol buffers. Protocol buffers are also developed by Google, and they go as far as to, I think, 2001. Somewhere there, protocol buffers has been, I think, open sourced. So by default, gRPC uses protocol buffers, but actually, gRPC is not it's also payload agnostic, so which means that you can use other things than protocol buffers. For example, you can use Thrift, or you can even use JSON or something like that. But okay, so what are protocol buffers? So protocol buffer is an IDL. It is a way of describing the messages and services that we have. So it is language neutral, it's platform neutral, and it's fast, small, and simple, which makes it great. The basic building block of protocol buffers are messages. So message is the object which we are sending. Sorry, that's my mobile phone. Okay, thank you. Okay, oops. So the message is the standard, the basic building block in protocol buffers. So message consists of fields. Fields are basically the properties of the message, and each field has a strongly typed type that we associate with a field. So for example, we have a search request message, which has a query field, which is type of string. And we have also page number, which is type of integer, size 32 bytes. And so we have also some numbers here. The number is a tag number. It is kind of it's an identifier of the field. So those numbers allow us to version our messages. So for example, okay, I will skip that part in the next slide. Okay, so if, for example, we want to drop a field from our message, we must reserve the tag number that was associated with that field, because some future developers, when they come on the project, they might accidentally use the same tag number that was used previously, which can lead to data corruption or even privacy breaches. So basically, we have to reserve deleted fields in order to prevent unintended behavior. We can also reserve fields by their alias name, or we can specify a range of numbers. Also, protocol buffers allow comments to be specified in the Proto files, which is great because we can also put our documentation right beside our definitions. So protocol buffers also support repeated fields, which are basically arrays. So we have a message place order request, which specifies an address where the items have to be delivered, are being ordered. So this is basically implementation of an array. We can also have a map fields, which is just a standard map. And as you can see, we can also embed other messages into our messages. So we can reuse messages, which is pretty nice. We can have one-off fields. One-off fields is a field which can have multiple types. But once you define the actual field which will be used, so either image URL or image data can be used. And once you define one of those, the same memory space will be used for the both. So it's really efficient. Then we can have enum fields. Nothing too interesting about that. And finally, we have service definitions. So service definition is a definition of the procedures that we will be using in our services. And service definition consists of RPC keyword, and we specify the messages that will be called, that will be passed to our RPC and returned from our RPC. So that's a basic concept. Okay, so there are different kinds of RPC functions that we can have in our applications. We will now see what are those. So the first one, the most simple one, is Unary. So a Unary RPC call is the one that we are using every day in our applications. It's a function that you call with some parameters, and that function returns something to you. So one message is being sent over the network, and one message is being received. We can have client-side streaming. So client-side streaming is when a client sends multiple messages, and once the server says, once the client is finished with the messages, the server can respond with the final message and close the connection. Then we have server-side streaming. So the client sends initial message, and then the server takes off by sending stream of messages. So for example, the server can send multiple full response messages to the client. And finally, we have bi-directional streaming, which is multiple requests and multiple responses. This is pretty powerful because you can define custom workflows just with this. So the client can send a message, and then the server can block until the message is received, and then the server can respond upon that message. But you can also implement the logic where the client and server are independently sending messages. So you can have all kinds of variations of your workflows with this bi-directional streaming. You can implement many use cases with it. So let's take a look at the standard way we use today with JSON. So with JSON, we have some interesting problems, such as, first of all, JSON is loosely typed. I mean, it doesn't have any types. So we have to carefully specify in the documentation what are the fields, and somebody has to read the documentation and create the JSON object manually by reading the documentation. So there's a person who is doing that is us developers, and there's always a chance that something might go wrong. You might make a typo by creating a custom object, and that stuff happens. So for example, we can have an uppercase field and expect a lowercase field name. So that is a common problem. Or we can have even missing fields, which have to be validated somewhere. Or we can even have wrong types that we are expecting on the other end. So let's see how protocol buffers handle that. Protocol buffers don't have that problems because protocol buffers are strictly typed. We define a type, so our message is defined, and we cannot deviate from that. There is no space for human error. So our IDE will tell us an error if, in case that we make a typo or something like that. So basically, protocol buffers are in this case like a contract between our services or client and services, which is pretty nice because we have a single source of truth and we don't do human mistakes there. So there's a difference in performance between JSON and protobuf. JSON is a text format. So once you send a JSON request, you are sending basically text over HTTP. But protocol buffers are serializing your message into binary format, which is much more efficient. And for example, 58 bytes of JSON fit only 13 bytes of protobuf, which is 22% of JSON size. This is a benchmark for Java to Java communication. So protobuf takes only 43 milliseconds, while JSON takes almost 200 milliseconds, which is a pretty big difference. With JavaScript Java communication, we have a slightly worse performance, but that's mostly because when we are in JavaScript, we already have a JSON. So we start from JSON, and therefore we have worse performance because we are parsing from JSON to binary. While in Java you have a object which is in memory, Java object, which you marshal into binary. So it's faster in Java, of course. Okay, so that was a little bit about gRPC and gRPC-Web. But I'm here today to talk about gRPC-Web. So gRPC-Web is a new specification which enables us to use gRPC on the web. So we can have browsers that can talk to backend services via gRPC. So in order to use this gRPC web specification, there are three main components that we must use. So the first one is gRPC-Web proxy. gRPC-Web proxy is a small reverse proxy which enables us to send messages, gRPC messages from the browser to the server. And then we have the protocol buffer compiler plugin, which will generate the TypeScript files definitions for our protocol buffer definitions. And finally, we have gRPC Web Client, which is the library that actually does the gRPC calls via HTTP2. And also, it works in Node.js, of course. I should also note that there are actually two libraries that work with gRPC Web specification. One is developed by Google, and the other one is developed by Improbable. But in this talk, I chose Improbable's library because they are using it in production, and they started the TypeScript support much earlier than the Google version actually did. So I think that their version is a little bit more mature, I would say, than the Google's version. Okay, so gRPC Web Proxy has some basic features that come out of the box, such as we have structured logging of the requests that go through it, and they are printed to the standard output. So it's easy to have logging. You get it out of the box. You also get the debug endpoint, which you can use to see the requests. And you have Prometheus monitoring that is already implemented on the metrics endpoint. Okay, so in order to compile the Proto files into the TypeScript files, we need to use the tsprotos-gen library, which will basically take our protocol buffer definitions, and it will spit out the TypeScript and JavaScript files. However, gRPC Web is limited by some browser limitations. So gRPC Web Client uses Fetch API to do the HTTP2 streaming. But the Fetch API does not implement the client-side streaming, only server-side streaming. So we can't actually stream from the client. But it's not that big of a deal because we can still implement a lot of the use cases with server-side streaming and Unary requests. Also, one interesting thing about gRPC is that there is only 15 status codes that you can use in your applications. So usually we are using a lot of HTTP status codes. There's plenty of those. But Google decided to go with only 15, which appear to be sufficient for all use cases. Also, there are some built-in authentication mechanisms. We can use SSL or basically TLS, it's the same thing. Or we can have token-based authentication. So TLS is probably more applicable in the inter-service communication, where you have two services and you want them to verify their identity. While token-based authentication is more practical on the front ends, like you want to authorize a client and you will give him a token that he will authorize with. This is an example in Java of the TLS security. So basically, you're just providing the PM file, and it's easy as that practically. So token-based authentication, this is an example from the web client. So you just create a browser header subject, and you set a header authorization with a token, and that's it. Now on the server, you need to implement some kind of interceptor that will take the headers and authorize the user. So it's pretty simple to implement that stuff. Also, in case you have Swagger documentation, you can auto-generate the protocol buffer definitions from that Swagger documentation with a tool that was created by New York Times. So they're also using the gRPC as well. So now it's demo time. Let me just switch. Oof. This will be difficult. Mm-hmm. Is it okay? Okay, I should fix this resolution. Vraćamo display. Okay. Okay. Okay, cool. Okay, so here I have a Proto file in which I define the greeter service. And the greeter service implements only one method, say hello, which takes these two messages, this message is taken as a parameter, and this message is being returned from the function. So once you create a service definition like this one, you can run the protocol buffer compiler, or called Proto-C. Let me first show you. So basically, it's just a standalone binary that takes a bunch of plugins, and you give it the directory where or basically you give it the Proto files, and it will generate the client libraries for your services. So here we specified JavaScript and TypeScript, and also Go. So we have a backend in Go, and we will have a client in JavaScript. And now we will run the compiler, and compiler will just generate the libraries for us. So here on the backend, this is the file generated by the Proto compiler. So this is Go code, which includes all the messages that we've defined in the Proto file, and also the setters for the setters and the getters for the messages. And for the front end, we also have equivalent in JavaScript. So this is common JS that can run in browser, and we also have the generated TypeScript types, which will enable the IDE auto-completion and all the good stuff. So let's take a look at the implementation on the backend. So this is the implementation of sayHello method. It takes the context and, most importantly, request and reply message that we've specified in the Proto files. And here we can implement the simple functionality, like we will just take the name that was specified in the parameter and we will return it to the user. So let's go to the front end now. Okay. I can scroll down. Demo. Okay. Okay, so here we have a simple React component which has a button, an input, and basically we take the input from the input field, and when the user clicks the button, we will call the RPC function that we just saw. So basically, here we have the firstly we created the greeter client. So here we specify the address of the gRPC server, and once we have the client, we can invoke the functions on the client. We also have to create the request and set all the fields of the message. So just to show you, you have all the generated getters and setters. And you cannot type in wrong types. Okay, I should get an error here. Probably. Okay, that's strange. I think this is the issue. Okay. Well, anyways, let's test it out. Okay, I need to firstly start the backend. Okay, so I'm gonna type in, and I'm gonna say hello, and we have an error. Okay, I forgot to do one thing, which is we need to start the gRPC proxy, web proxy. So basically, we just run it as a standalone library here, but you can also run it from a Docker container. So I'm just going to specify this backend address is the actual address of our gRPC server. And I'm going to disable TLS here, and let's start it. So the proxy is started now, and we should be able to, I hope. Yeah, OK. So what happened here was we made a request via gRPC. and it went through our proxy, which talks gRPC-Web and translated it to gRPC, native gRPC. Okay, and now what happens if, for example, I change this field to, I don't know, username, and I run the compiler again? Now we're getting a TypeScript error, which is saying that there's no set name on the hello request because we just changed the field name. So that is pretty nice because now we have a single source of truth and we don't have to wait for the exceptions to come at runtime. We can see them in our IDE right before we start the application. So I'm just gonna change this to set. Actually, I'm just going to roll it back because I will have to change the backend as well. Okay, so now I have one more example which will use the streaming feature. So this final demo, I created a little app which will call the Twitter API, and the Twitter API will listen for some tweets by hashtags, and our API will stream the new tweets to our client. So let me show you how the protobuf files look like first. So we have a Twitter service which implements getTweets method. So that method will take getTweets request, which will take a repeated field hashtags, which is type of string. So this is an array of strings, and that method will return a stream of tweets. And one tweet is basically just an object with author, text, and image URL. So on the backend, this is how we implemented the function. Basically, we are calling the Twitter stream, which will give us all the tweets in real time. And then we get the stream from the gRPC call, and we will just send all the tweets to the stream. So, okay, let me clarify a bit better here what's happening. So we are creating for each tweet that happens, that we receive from the Twitter API, we will create a new tweet message. And this tweet message is also auto-generated by the Proto compiler. So if I go here, we can see all the fields that we specified in the Proto files. So we just create a tweet. We set the text, the name of the user that sent the tweet, and we're gonna also save the image URL that was posted with the tweet. And then we are pushing that tweet through stream to our client. Okay, so now that should be running. And I will go here now. Okay, so we will listen for JS-ZGB tag or hashtag. And basically, what's happening here is we will call the getTweets function, and we will provide the hashtags that we are listening to. And for each tweet that we receive, we will just save it to state and render it on the screen. So we should see in real time the tweets that we receive. And this is all done through only one request. There is no long polling. It's not via WebSockets. It's just HTTP2 push. So to test this now, you can help me out. So if you have Twitter, you can actually tweet. Where's my phone? Thank you. So if you also, I should say, the first 2 tweets will get a reward. So I'm giving out 2 ESP32 microcontrollers, which you can program in JavaScript. Okay, I will give those later. But first, what you need to do to win this is you need to tweet an image with the hashtag JSZGB. Who's gonna be first? Oh, we have 1, we have 2. So we have the winners. Okay. So basically, this just, I'm gonna give you the rewards after. So basically, what just happened is we have only one connection open with the server, and the server is pushing the data through a stream. So that's the gRPC magic. So basically, that's it with the demo. I should go back. Okay. Okay, so to close this up, here are some of the reasons why you might consider gRPC on your next project. Firstly, you don't have to hunt down the API documentation because it's right there where you define it. It's self-explanatory. There's also one more cool feature that you can do with protocol compiler that I will show you quickly. Okay, so there's no more handcrafted JSON objects. There's no space for human error. You don't have to deal with a bunch of methods like post, put, get, and there's only few status codes that you use to describe the status of a call. Only 15 status codes. HTTP2 multiplexes the connections through only one connection, which saves bytes. It's more efficient. And you get streaming out of the box. So you don't have to have a front end that has WebSockets and HTTP client together. You get it all in the same box. So thank you everyone for coming, and I hope that you had fun and that you learned something.
Okay, thank you, Ante. And any questions? Okay, thank you.
No questions, really. Okay.
Okay, Janez, stage is yours.
will present you something about Firebase. We will explore the good, the bad, and the ugly parts of this platform. I'm Janez, I'm from Ljubljana, Slovenia. I work at an agency called Polio Labs. We do mostly web stuff like web apps, websites, and mobile apps for US-based startups. Here are the three things I like. I like teaching web development. This is the first icon. I like working out, and I like music. And the band I really like is the punk rock band from Zagreb called Berkeley. Yeah. Before we begin discussing the internals of Firebase, I want to get to know you a little bit. How many of you, like by the raise of hands, have ever heard about Firebase? Yeah, like most of the room. And how many of those have ever used Firebase? Like half of the room. Okay. So Firebase, for those who haven't used or heard about Firebase, Firebase is a development platform. It emerged as a startup, and it was later acquired by Google in 2014, I think. Firebase is not a single product. Like many people think that Firebase is just a real-time database, but no, Firebase is a whole suite. And currently there are 18 products in the Firebase suite. So you have everything from like development products like database, storage, authentication, to tools that help you manage your apps, like catching errors and so on, and tools that help you find more info about users, like A/B testing and so on. And Firebase, the idea is that it's a serverless platform. But what is serverless? Serverless still runs on servers. But in this case, everything is managed, everything is run by Google on their Google Cloud infrastructure. So you are spared of those time-consuming tasks like spinning up servers, managing them, deleting those servers. And for us, for developers, it's mostly okay because we can focus more on developing apps and less on the whole infrastructure. Okay, the case study. So we developed an admin and internal tool for a US-based startup where we track fleets of vehicles on the map. And then our customer can use this map to power on the vehicles, power off, manage them, and so on. And because this involves a lot of moving vehicles, we leverage a lot of real-time products from Firebase, like real-time database. This is the old database, and the new one, the Cloud Firestore. What else we also use from Firebase suite is authentication and cloud functions. So because it's a serverless, those cloud functions are similar to like Amazon AWS Lambda. So HTTP endpoints, which you can call from your app. And another cool function about cloud functions is that they can serve as database triggers. So when something changes in your database, the cloud function will be run. Okay, there are many other products in the suite I didn't cover, I won't cover, but as far as I know, there are more geared toward mobile app development. So this Firebase thing is mobile first. So let's explore the good parts of Firebase that makes our life really easy when developing. The first would be the Cloud Firestore. So this is a new version of their real-time database. It's a NoSQL type of database, and it has collections and documents. Under documents, you can have also sub-collections, and everything is real-time, it's really fast. It implements WebSockets in the background. So what you can do is a single fetch, a get of data, or you can set up a listener and receive changes from the either collection or document. So you are observing writes, reads, and updates. It's really automatically scalable. So in the first version of this database, the real-time database, you had to shard your data across multiple instances, but Cloud Firestore is scalable out of the box. And another thing you need to do when you're doing some querying, you need to create indexes. But those are really easy to create, especially in this Firestore. You just get a link, you click on it, you get to the Firebase web UI, and just create. This is a little bit out of context, but next we will look at security. And basically, the Firebase authentication has all the things security covered, so we don't need to deal with it. So Firebase authentication is their answer to maybe OAuth 0 or some service like that. So you get password, phone, or anonymous authentication, and you also get support for federated identities. Those are the OAuth third-party logins like Google login, Facebook login, and so on. On the front end, we are using React, and you can use, in JavaScript, you can use their official library called Firebase UI Web. And for React, you have the React wrapper, Firebase UI Web-React. Yeah, what you get from this library is you get signing, you get register, you get automatic validation for everything, these types, and you get the password resetting as the whole thing. Okay, another really good thing about Firebase is hosting. It's really simple. If you're building a React app, a JS app, you can deploy it to a global CDN, content delivery network, and everything is automatically served via SSL. So your things are secure. And when you create a point in hosting, you get a Firebase app.com domain, but you can easily connect your own domain to via the portal. And in this Firebase UI portal, you also have the latest deployments listed, and you can, by a single click, you can roll back to a previous version, which is really nice. Okay, let's focus more on the bad and the ugly stuff. So here are some things that are bad, at least we noticed, and we think they are bad. And I will present the problem, and then I will present a solution to mitigate this problem. First, the security rules. Security rules for the database are defined like this. Here's an example. So we have rules for users collection, and everything in users, every document has a right rule that only the authenticated user with that UID can write to the users that collection. So this is a bit cumbersome, and also every rule for the database has to be defined in this JSON. So one thing to improve that is you can define functions inside this JSON. And a good idea for this would be to keep this JSON in version control and deploy from version control. So in Firebase, you have this CLI, which you can use to deploy your app, and you can also use to deploy your rules. One thing to watch out also is the cost of, here is the cost of the database, which is usually the biggest spender. Firebase Cloud Firestore is free, but you are limited to the bandwidth and to the writes, reads, and the reads. And here is a screenshot of their Spark plan, where you're limited to 10 gigs per month of bandwidth, and you are limited to 20,000 K of writes per day, and so on. Once you exceed those numbers, it can get expensive really quickly. So there are some things to watch out. And one thing is you can find the whole blog post of this on Medium, is that one team used Firebase and this pricing, and they implemented a mobile app which used a feature from Firebase called offline persistence. That means that everything is kept offline, so you can work with your app while offline, but that means constant syncing with Firebase. So do I have the latest data? No, okay. And this syncing was, so they paid like 2,000 euros for a few users because of this syncing. And one thing also is to be careful with the bigger database reads, because you have only limited document reads. So we briefly mentioned cloud functions before, and all cloud functions in Firebase have to be defined in one big index.js file. And this is quite not ideal. So one thing to remediate this would be to keep each cloud function to its own file, and then just include them in one index.js file. Also, the whole development, the feedback loop of developing those functions is quite slow. It's hard because for some things like database triggers, you need to deploy before you can test it out. You need to deploy to test it. But for other normal cloud functions, you can spin them up locally. So you can use the Firebase CLI for that, and you can test locally. When deploying those functions, you can deploy all, or you can deploy just one function. So this will be faster. So cloud functions, similar to Amazon Lambda functions, when they are not used, they become cold, and when you use it again, the cold start occurs. That means that up to 10 seconds before you get response from that function. One idea would be to use the cloud functions only for writes or updates and read directly from the database, because it's fast, it's via WebSockets. Okay, so when you're writing your cloud functions, you'll sometimes feel like this. Okay, let's see the ugly parts. I will present only one ugly part. Maybe those who have already worked with Firebase know this. It's the biggest pain. We also noticed that the queries. You can do only simple queries in Firebase, even in the new Firestore. Let's see some limitations, what you cannot do. First, you cannot do compound queries with range. For example, from user, get me age greater than 50 and height greater than 150 centimeters. You cannot do that. You need to query both and then merge it on the client or in the cloud function if you want. You cannot do or queries. So you cannot query like this, where name is Janez or Janez. And you cannot query by a field which is not defined in the database. Like, for example, we have some deactivated users with a flag deactivated true. You cannot get users without that flag. So some solutions would be, so for the first one, you need to merge it. You can merge it in cloud functions that will help you with bandwidth. You get only the data you need from cloud functions. The second one would be the same, merge it. And the third one would be, so you can set all the other users to explicitly deactivate the false, and the query would work. You can also, one issue is also the getting totals or counts from the Firestore. You cannot do that when you do a get or a snapshot. When you listen for a snapshot, you get all the data, just the data. So you could do is that you could spin up a cloud function that would aggregate to a field. So once you write to your database, you can do an aggregated field, and then just query that field. And for some full-blown search, like you have employees that need to search users from Firestore, they recommend using other services, like search services, like Elasticsearch or Algolia. So when to use Firebase? What we notice is that Firebase is really good for prototyping. It offers you everything from database, from hosting, authentication, and you can get started in like a matter of hours. When I was doing these slides, I sometimes use this online editor called StackBit, which is like VS Code in the browser, and they have an option especially for deploying to the Firebase hosting, because it's so easy. So prototyping, or if your app needs real-time requirements, those are like chat apps, IoT apps, and so on. Just be careful, because if you have some really relational data, it may not be the best idea to store it in this real-time database because of the query limitations. And you can split the real-time data and relational data. You can put in some managed SQL database. Because Firebase sits on the top of the Google Cloud infrastructure, you can find some other products there. So, yes. Thank you.
Okay, thank you. Any questions? So, no? Okay, everyone, you can stay here for a bit. I'm not sure how much longer can we stay here before 5 kicks us out. So we can hang out, chat, and we can go for a beer or something later. So yeah, that's it. Enjoy your holidays and see you next year.